Hello there, and welcome to the Sleepless Scientist, a quiet place in the cosmos where your thoughts can unwind and knowledge becomes a soft lullaby for the night. Tonight's journey will take us beyond what we can see, into the unseen gardens of reality itself, into the strange idea that there may be countless versions of this universe, quietly unfolding beside our own. They may not be far away at all. Perhaps they share the same space, just vibrating at a different rhythm, like two songs playing softly on top of one another. But before we settle in, please take a moment to like this video and subscribe, only if you truly enjoy these quiet explorations into science and wonder. And when you're ready, leave a comment to let me know where in the world you're listening from and what time it is for you right now. It's always such a joy to see all the places we gather from, each in our own little slice of time. Now, feel free to dim the lights, pull a blanket a little closer, or let the gentle hum of a fan become your quiet background companion. There's no rush here. If your mind begins to wander, that's perfectly fine. Let it drift, like starlight across the dark. We'll still be here, quietly unfolding the story, one calm thought at a time. Long before telescopes or equations, human beings already looked at the sky and imagined other worlds. The Greek philosophers, those early dreamers of atoms and stars, spoke of infinite little building blocks colliding in endless combinations. They believed that somewhere, beyond the reach of their eyes, there were other Earths, other suns, other lives. Democritus imagined them spinning in the void, while Epicurus whispered that these other worlds might follow the same natural laws as ours. It was a simple, daring thought. If nature's recipe works once, why wouldn't it work again? Far to the east, Indian scholars told stories of cosmic rebirth, universes blossoming and fading like seasons. In their view, creation wasn't a single event, but a breathing rhythm of existence. Expansion, collapse, renewal. Worlds were born, destroyed, and born again, like waves endlessly curling and retreating upon the same eternal shore. When you listen to that ancient idea, it doesn't sound so distant from what we now call the multiverse. It sounds like an intuition older than science, an instinct that the cosmos never repeats exactly, but never truly ends. Centuries later, during the Renaissance, a quiet man named Giordano Bruno would stand beneath those same stars and feel the old intuition stirring again. He believed the universe was infinite, that every point of light in the night sky was a sun like ours, each surrounded by its own family of worlds. He said softly but defiantly that the cosmos had no center, that divinity was everywhere. For this belief, he was imprisoned and eventually burned. The fire that took his life could not take his vision. He had dared to imagine infinity, and in a sense, we have been chasing his imagination ever since. There's something strangely human about our need to multiply the world. Perhaps it's the same curiosity that makes us wonder what would have happened if we'd taken a different path, written a different letter, or said one more word before walking away. The idea of infinite worlds has always been a mirror for that feeling, a way to imagine that every choice, every heartbeat, continues somewhere else. When you stare long enough at the night sky, it begins to feel like a hall of mirrors, each reflection stretching farther than the last, each one whispering a slightly different story of who you might have been. As centuries passed, our instruments sharpened. The telescope became an eye of glass and metal, and we began to measure the vastness Bruno had only dreamed of. The observable universe, that faint sphere of light we can still detect, is 93 billion light-years across. Even that number is too large for meaning. If you travelled at the speed of light, you would still never reach its edge because the edge is always running away from you. And yet, what lies beyond that horizon might be more of the same. More galaxies, more possibilities, maybe even another Earth looking back at us through another telescope. Mathematics tells us something curious. If the universe is infinite and matter arranges itself in all possible ways, then eventually the arrangements must repeat. Somewhere, far beyond what any spacecraft or beam of light could ever reach, there must exist a region identical to ours. Another solar system, another planet, another you, sitting in a room that feels exactly like this one. The thought feels both comforting and eerie. If reality is infinite, then everything that can happen does happen. Somewhere. Of course, infinity is a heavy word. It's not just a number. It's a confession of our own limits. When we say infinite, we're admitting that we can't see the boundary, can't hold the whole picture in our minds. But infinity has always been the natural language of wonder. The atomists didn't know about galaxies. Bruno didn't know about relativity. The poets who imagined eternal cycles never wrote equations, yet all of them, in their own ways, reach toward the same horizon. That there's more to reality than the small patch of existence we call our own. And maybe that's why the idea of many worlds has survived for so long. It's not just a scientific question, it's an emotional one. It lets us imagine a universe generous enough to contain all our possibilities. Even if we can't reach them, it's enough to know they might be there. Quiet echoes of our own lives, waiting in the endless distance. As we drift further into the story, our attention turns from the vast and ancient to the small and uncertain. We leave the sky and descend into the unseen, into the place where light wavers, particles hum, and reality begins to split not across space but within itself. In that microscopic twilight, a new kind of infinity waits, one made not of stars but of possibilities. If we follow the thread of infinity a little further, we arrive at an even stranger realization that there isn't just one way the universe could multiply itself. There are several ways it might have already done so. Each theory is like a different window looking out over the same endless landscape, and each one paints a slightly different view of how reality could repeat, divide, or overlap. None of them cancel the others out. Together they form a kind of cosmic symphony, 3 melodies, all playing at once, describing an existence too vast to hold in a single key. The first idea is the simplest, and perhaps the most ancient. It's called the infinite cosmos. In this view, space itself never ends. You could travel in any direction forever and never come back to where you started. The stars do not form the edge of a great sphere. They are just the beginning of an ocean with no shore. And if that ocean truly has no boundary, then its waves, the galaxies, the atoms, even the thoughts that rise and fade, must repeat eventually. It's the mathematical version of déjà vu. Given infinite rolls of the dice, every outcome must appear somewhere, even if separated by distances so immense that light itself could never cross them. Imagine a library that never ends, filled with books written in every possible combination of letters. Somewhere in that library is your story, written word for word exactly as you know it. And somewhere else, another version where one sentence changes, one breath is held a little longer, one decision unfolds differently. A universe of alternate editions, each waiting on a shelf that stretches beyond all reason. That's what an infinite cosmos implies. Every possible arrangement of matter eventually exists. Somewhere, there is another you listening to this very thought, perhaps with a slightly different voice or under a slightly different sky. The second idea takes a more dynamic view. It's called the bubble universe theory. Instead of one infinite sheet of space, imagine a great cosmic froth. Each bubble a separate universe, floating and expanding in a sea of others. Ours began as a single spark of expansion, a tiny point that swelled faster than light in what we call the Big Bang. But there's no reason to think it happened only once. The physics of inflation, that brief moment when energy inflated the newborn universe, may still be happening elsewhere, in regions we'll never see. Each time it occurs, another bubble forms with its own time, its own laws, its own possibilities. Some bubbles may grow, collide, and merge. Others may drift apart forever. And if two universes ever brushed against each other, the memory of that encounter might still linger, a faint fingerprint on the sky. Astronomers have looked for such traces in the oldest light we can see, the cosmic microwave background, the afterglow of the Big Bang. There's a region there called the cold spot, a patch a little dimmer and cooler than the rest. Some believe it's a coincidence, or the shadow of a vast cosmic void, but others whisper that it might be the bruise left behind by another universe colliding with ours, long before the first stars began to shine. Whether or not that's true almost doesn't matter. The image is enough to make the imagination tremble. Two universes touching, like soap bubbles in a quiet bath, leaving ripples that echo through eternity. The third idea is perhaps the strangest, and yet it may be the most intimate. Unlike the others, it doesn't stretch across space or time. It lives right here, in the invisible architecture of the smallest things. It's called the quantum multiverse, or more poetically, the many worlds interpretation. This idea doesn't require new universes to appear in distant regions of space. Instead, it says that they branch constantly, everywhere, at every moment. Each time something could happen, all the possible outcomes do happen, each in its own world, its own timeline, its own silent reality. When you toss a coin, it doesn't land only on heads or tails. In one branch of the universe, it's heads, in another, tails. Both outcomes exist, but each is unaware of the other. The coin, the air, even you, all split invisibly, continuing along separate paths that will never meet again. It's a difficult thing to picture, but there's a gentler way to feel it. Think of your life as a tree. Each choice you make, each word you say, sends out a new branch. You keep climbing upward, following one path, but the other branches continue to grow too, each carrying a version of you that turned left where you turned right. Most of those versions you'll never see, but somewhere in the great forest of reality they're still moving, all part of the same cosmic trunk rooted in the same soil of possibility. In this sense, the multiverse is not distant at all. It's not hidden behind galaxies or locked inside equations. It's right here, in the quiet spaces between moments, in the shimmer of uncertainty that lies beneath every atom. The air you breathe, the light touching your skin, the thoughts drifting through your mind, all of them are quantum systems, vibrating between possibilities until observed, until chosen. It's as if the universe keeps every door open until someone walks through one. And what happens to the other doors? They don't close, they simply lead elsewhere. The physicists who propose these theories aren't trying to write poetry, but they can't help it. The language of the cosmos has a way of becoming beautiful, even when written in numbers. Whether the multiverse is infinite, bubbling, or branching, all three ideas point to something quietly profound. The universe might be bigger than the concept of everything. It might contain every possible version of itself, woven together like threads in a tapestry that never repeats and never ends. For now, we can't step outside our own thread to see the whole picture. We live inside one pattern, one melody, one thin beam of possibility. But knowing that the greater song might exist, hearing even a faint echo of it in our imagination, can be enough to fill the night with wonder. As our quiet exploration now turns inward, we'll leave behind these vast cosmic panoramas and begin to shrink again, following the story down to its smallest stage, the realm of light and electrons, where reality behaves less like a solid thing and more like a thought deciding what it wants to be. In that flickering space, science begins to whisper something almost mystical, that the multiverse might not just be out there, but within everything that exists, including you. If we follow the trail of these ideas a little further, we find ourselves standing between two kinds of infinity, the infinity of imagination and the infinity of mathematics. For most of human history, those two realms were the same. When people spoke of eternity, they meant wonder, not calculation. But as science grew more precise, we began to put numbers to our awe. We started to measure the immeasurable. And even that, it turns out, did not make the universe any smaller. It's easy to think of infinity as something abstract, but it's really a shape made of curiosity. The mathematician sees it in the endless line that never closes on itself. The physicist sees it in the expanding sky. The dreamer feels it in the strange awareness that there must be more than one version of themselves, that somewhere another you is standing in a slightly different light. Infinity isn't just the absence of boundaries, it's the presence of possibility. When modern physics began to take form, it tried to make sense of that possibility. Newton had already drawn the blueprint for how objects move and how planets stay in their orbits. His laws described a universe of perfect clockwork, where every motion followed a rule. It was comforting, predictable, almost musical in its precision. But as the instruments of science became more sensitive, the music began to falter. There were notes that didn't fit the melody, small mysteries that refused to obey Newton's rhythm. One of those mysteries appeared in the study of light. If light was made of waves, like ripples on water, then it should spread endlessly through space. But sometimes it behaved like a stream of tiny particles, little sparks that could bounce or scatter. Scientists tried to measure the pattern, to write formulas that could explain both stories at once. But the more they measured, the stranger it became. Light seemed to forget what it was until you asked it a question, and then it answered in whatever language you expected to hear. In the late 19th century, a quiet German physicist named Max Planck faced a problem that no one could solve. He was studying how hot objects give off light, what colour the glow becomes as temperature rises. According to the rules of classical physics, a hot object should shine infinitely bright in violet and ultraviolet light. That was nonsense, of course. No one had ever seen an object glow with infinite energy. The equations were wrong, and no one knew why. Planck thought about it differently. He suggested that light didn't pour out in a continuous flow, but in tiny packets, little bundles of energy. Like a piano that can only play certain notes, the universe, he said, only allows energy to exist in specific steps. He called these steps quanta, from the Latin for how much. That small, hesitant idea quietly changed everything. It was as if Planck had discovered that the cosmos was not a smooth canvas, but a mosaic made of tiny tiles, discrete, indivisible, and endlessly complex. His idea solved the mystery, but it also cracked open a door that no one could close again. Suddenly, scientists realized that the universe might not behave like a solid machine at all. It behaved more like a symphony that could improvise. Every particle, every flicker of light seemed to follow its own secret rhythm. Predictable in patterns, but unpredictable in detail. If the laws of nature were a song, they were written in a key that humans could hear only in echoes. The next generation of scientists stepped through that open door. They began to describe the world not as a collection of things, but as a dance of probabilities, waves of potential that could collapse into a single outcome only when someone looked. Mathematics could describe these waves with remarkable accuracy. A certain curve could tell you where an electron was likely to be found. But when you went to look, it never appeared as a wave. It appeared as a single, tiny point, as if reality itself chose one version of the truth just in time for you to see it. It's tempting to think that this is only about physics, but it feels oddly familiar, doesn't it? In our own lives, possibilities unfold like invisible waves. Before we make a decision, everything feels open. 1,000 futures shimmer in the distance. Then we choose, and the wave collapses. The world becomes solid again. We never see the other possibilities fade, but we feel them, lingering like ghosts of choices that could have been. That moment, when the infinite becomes specific, is something we all experience. It happens in the second before you say yes or no, before you turn left instead of right, before you open a message or leave it unread. We don't think of these small pauses as acts of creation, but they are. Every decision is a tiny version of the universe choosing a path. And just as in quantum physics, all the other outcomes don't vanish. They simply drift into worlds we cannot reach. When Planck introduced the quantum, he couldn't have known what it would lead to. His modest proposal about light would soon ripple through science, art, and philosophy. The equations that followed would become the foundation of the quantum revolution, the stage on which reality itself would start to blur. But beneath all that mathematics, there was something deeply human. A sense that uncertainty was not a flaw in the universe, but a feature. That maybe we were never meant to know everything at once. That the act of looking, of being conscious, might be part of the way the universe becomes real. And so, between stars and equations, between curiosity and calculation, a new kind of infinity was born. One not written in the vastness of space, but in the trembling of the smallest things, an infinity made of choices, chances, and quiet possibilities, all waiting to be seen. From here, the story opens into that microscopic realm itself, into the twilight world where particles and waves are the same, and where the act of observing is the same as creating. It is there, in the smallest spaces imaginable, that the idea of many worlds begins to take shape. As our quiet exploration now turns to the smallest scales of reality, we begin to enter a place where language itself seems to lose its footing. The world beneath the atom isn't made of the familiar things that fill our days. It isn't like pebbles or dust or droplets of water. It's something more fluid, more uncertain, a sea of shimmering probabilities that flicker in and out of being. When you look too closely, the universe begins to whisper instead of speak. The story begins in the early 1900s, when physicists were struggling to understand what holds the world together. They had uncovered a whole zoo of invisible pieces, electrons, protons, neutrons, and believed that with enough equations they could map how everything moved. But the deeper they looked, the more the rules slipped through their fingers. Imagine the universe as a grand orchestra. For centuries, scientists believed it played a song of perfect order, each note predictable, each rhythm following a steady beat. But as they tuned their instruments to listen more closely, they began to hear something unexpected. Faint improvisations beneath the melody, harmonies that didn't quite belong yet fit beautifully. The universe wasn't reading a sheet of music, it was composing as it played. One of the strangest instruments in this orchestra was light. Sometimes it behaved like a wave, spreading gracefully through space, bending around obstacles, merging and interfering with itself like ripples meeting on a pond. But at other times, light struck matter like tiny bullets, discrete packets of energy that bounced, scattered, or vanished on contact. It was both continuous and separate, both wave and particle. It was as if light had a double life, and chose which one to reveal only when we looked. This dual nature was beautifully captured in an experiment that remains one of the most poetic in all of science, the double-slit experiment. If you shine light or electrons through two narrow openings onto a screen, something strange happens. You don't see two bright lines, as you would expect from two holes. Instead, you see a pattern of many bright and dark bands, a soft interference pattern, the kind made by waves overlapping. It's as though each particle passes through both slits at once, whispering to itself across space. But when someone places a detector by the slits to see which path the particle actually takes, the pattern disappears, the waves vanish, and two clean lines appear instead, the signature of solid, singular particles. Simply watching changes the outcome. The universe behaves one way when unobserved and another when seen. It is a shy performer, altering its act depending on the gaze of its audience. To make sense of this, Danish physicist Niels Bohr offered a new way of thinking, one so strange it almost sounded mystical. He said that until measured, a particle exists in all possible states at once, like a spinning coin that's both heads and tails until it lands. This idea was called superposition. The act of observation doesn't just reveal the outcome, it decides it. In that instant, the coin stops spinning and reality makes its choice. Bohr called this framework the Copenhagen interpretation, and though it was born of pure physics, it carried a quiet echo of philosophy. The observer and the observed are part of the same story. Not everyone accepted this idea easily. To some, it felt like surrender, as if science had abandoned its claim to objectivity. Among the skeptics was a wry and brilliant man named Erwin Schrödinger. To test how absurd he found Bohr's interpretation, he invented a thought experiment that became one of the most famous in all of science. He imagined a cat sealed inside a box along with a tiny radioactive atom and a vial of poison. If the atom decayed, the mechanism would break the vial and the cat would die. If not, the cat would live. According to quantum rules, the atom exists in both states, decayed and undecayed, until observed, which meant, absurdly, that the cat was both alive and dead at the same time, suspended in quantum limbo until someone opened the box. It was meant as a joke, a parody of how far this new thinking could go. But in mocking it, Schrödinger had accidentally created the perfect metaphor for the universe itself. Every event, every possibility may exist side by side, invisible to each other, until awareness forces the world to choose a single frame of reality. What Schrödinger called waves of probability were described by a mathematical curve, a smooth, undulating shape that predicts where a particle might appear, but never exactly where. The curve can be imagined as a landscape of potential, peaks where existence is likely, valleys where it fades away. The formula itself is intricate, but its spirit is simple. The universe is not a collection of certainties, it is a field of maybe. When you think about it, there's something strangely comforting in that. Our own lives are built of probabilities, not guarantees. We make plans that may or may not unfold. We set intentions that sometimes dissolve into other paths. Just like the particles that make us, we live in a state of gentle uncertainty, choosing and being chosen by the moment. Maybe the laws of physics are not so different from the patterns of our hearts. What began as a scientific curiosity, a way to explain why atoms don't collapse and light sometimes behaves like a particle, had quietly turned into a meditation on existence. The quantum world seemed to tell us that reality is not fixed but fluid, that the act of noticing is itself a creative force. Every observation, every thought, is like the universe opening a door and stepping through. As the story carries us onward, we'll meet a young physicist who refused to believe that reality collapses at all, a dreamer who imagined that every possible outcome truly happens somewhere. For him, the cat in the box doesn't die, or live. Instead of one another, both events unfold, each in its own world, each as real as the next. His name was Hugh Everett, and his quiet idea would become one of the most breathtaking interpretations of all. The vision of a universe that never chooses, because it doesn't have to. From here, the story opens into a quieter kind of mystery, one that doesn't live in distant galaxies or ancient myths, but in the faint shimmer of light itself. It begins with a question so small it feels almost playful. What exactly is light? A wave, a particle, or something in between? The universe has been performing this riddle for centuries, and we've only just learned to listen closely enough to hear it. When scientists first began to study light, they imagined it like ripples on water, smooth, continuous, and endlessly flowing. And for a long time, that image worked. Waves could explain colour, reflection, and even the way light bends through glass. But the illusion began to break the moment someone tried to look too closely. Under the microscope of theory and experiment, light refused to stay simple. Sometimes it shimmered like a mist of particles. Other times it spread and merged like an ocean swell. It was as though reality itself was undecided, as though it hadn't yet chosen what to be. To explore this strange behaviour, physicists designed an experiment that would become one of the most haunting pieces of evidence in all of science. It's called the double-slit experiment, a simple setup with a secret soul. Imagine you have a small wall with two narrow openings side by side. If you throw tiny particles like grains of sand at that wall, you'd expect to see two lines form behind it, one for each slit. But when scientists sent light through those openings, something else appeared. Instead of two bright lines, they saw a series of alternating bands. Bright, dark, bright, dark, rippling across the screen. It was the signature of interference, the pattern made when waves overlap. Light was behaving as if it had passed through both slits at once, like a single mind holding two thoughts simultaneously. But then came the twist. When the experimenters placed a detector beside the slits, a small instrument to measure which slit the light went through, the pattern changed. The waves vanished. The alternating bands dissolved into two plain lines, exactly as if light had decided to act like a simple stream of particles again. Somehow, the act of watching had changed what was being watched. The very question, which path did it take, made the universe choose one. It's a difficult thing to grasp, not because it's complex, but because it feels so personal. The universe, it seems, behaves differently when it knows it's being observed. It's as if the cosmos itself has a kind of awareness, or at least responds to ours. When we look at the world, we don't just record it, we help define it. The boundary between observer and observed begins to fade, and suddenly we are part of the same experiment. This strange entanglement between attention and existence became one of the cornerstones of modern physics. Danish physicist Niels Bohr tried to describe it gently. He said that the quantum world doesn't reveal itself as something definite until we ask it a definite question. In other words, reality is a conversation, not a monologue. Until the question is asked, until the measurement is made. A particle exists in all possible states at once. It is not here or there, but both, not this or that, but everything in between. The equation that describes it isn't a number, but a smooth curve, a wave of probability that spreads across space like a sigh. When the wave collapses, when the measurement happens, that infinite range of possibilities narrows to one. The curve falls silent, the coin lands, the world decides. Bohr's interpretation was called the Copenhagen view, and it was both elegant and unnerving. It suggested that the world we see, this solid, everyday world of coffee cups and clouds and clocks, is just the thin surface of something far stranger. Beneath it lies a restless ocean of maybes, each waiting to be noticed. To look is to choose, and to choose is to create. It's tempting to think of this as pure science, but it also carries a quiet reflection about life itself. How often do we live in that same ocean of possibility, suspended between choices, both everything and nothing until we decide? The moment you act, one version of your life becomes real, and the others fade away, still humming faintly like parallel songs. The universe and the human mind are made of the same tension, a balance between what is and what could be. Albert Einstein, though he admired Bohr deeply, couldn't quite accept this idea. God does not play dice, he said, uncomfortable with the thought that chance ruled the heart of existence. Bohr's reply was soft but certain. Stop telling God what to do. To Bohr, uncertainty wasn't chaos, it was freedom. The universe's way of remaining open, alive, unfinalized. So what exactly is light? Even now we can't say with certainty. It's both wave and particle, energy and matter, presence and potential. It's a gentle reminder that reality doesn't always fit the tidy shapes our minds prefer. The same photon, that single flicker of light, can travel two paths at once, interfere with itself, and then, when asked directly, declare one version of truth. The deeper you look, the more you find that the world doesn't just exist, it becomes. Maybe that's the most mysterious part. Not that the universe hides its secrets, but that it seems to reveal them only when we are ready to listen. Like a friend who waits for the right moment to share a story. When you glance out a window at the morning light, you're not just seeing the world, you're participating in it. Your eyes, your awareness, complete the circuit. The light doesn't simply enter you, it acknowledges you. And perhaps that's the quiet gift the quantum world offers us. A reminder that observation, attention, is powerful. That by simply noticing, we help shape the very thing we're noticing. We become co-authors of existence, even if our signatures are written in invisible ink. As we drift deeper into this story, we'll meet someone who decided that reality never truly collapses at all. That all those possible outcomes, every wave, every branch, every unchosen path, continue to exist side by side in a vast network of parallel worlds. To him, the coin never lands. It keeps spinning forever, each side carving out its own version of the universe. If we follow the thread of curiosity a little further, it leads us to a quiet room, a sealed box, and a story that became both a riddle and a revelation. Inside that box lies one of the most famous creatures in the history of science, a cat that is somehow both alive and dead. Its fate depends on a single atom, a puff of poison, and the strangest idea physics ever whispered to the human mind. It's the story of Schrödinger's cat, a tale that began as a joke, but ended up reshaping the way we think about reality itself. The physicist Erwin Schrödinger didn't set out to confuse the world. He was, in many ways, a man trying to bring order to chaos. A decade after Max Planck had introduced the idea of tiny discrete packets of energy, those quanta that came in steps rather than flows, Schrödinger tried to describe how those packets behave. He wrote an equation, a soft mathematical rhythm that could predict how waves of probability evolve over time. He imagined each particle not as a dot moving through space, but as a smooth, vibrating pattern of potential. Something that could spread out, overlap, and interfere with itself, like ripples on a pond after a stone has fallen in. That formula, though never meant for bedtime reading, spoke a language the universe seemed to understand. It could describe the shapes of atoms, the colours of light, even the bonds that make matter hold together. But beneath its elegance was a quiet puzzle. It didn't describe one outcome, it described all of them at once. It said that every particle was a symphony of possibilities, a collection of notes that might play but haven't yet. Only when an observer looks does one note rise above the others, and the song becomes real. Schrödinger was uneasy with this interpretation, especially the way his colleagues at the Copenhagen school, led by Niels Bohr, seemed to accept it. If everything exists in multiple states until observed, he wondered, what happens to large objects? Does that rule apply only to atoms or to cats or to people? To expose how absurd it seemed, he invented a thought experiment that would forever carry his name. Imagine, he said, a small box sealed tight, containing a cat. Inside the box is also a single radioactive atom, one that may or may not decay within the next hour. If it does decay, a detector triggers, a vial breaks, and poison is released. If not, the cat remains unharmed. According to the laws of quantum mechanics, that atom exists in both states, decayed and not decayed, until someone observes it. And if the atom is both decayed and intact, then the cat too must be both dead and alive. It exists in a strange overlap, a twilight between two outcomes, suspended in uncertainty until the lid is lifted and the universe decides. It was meant to be absurd, a parody of the idea that observation collapses reality. But like many great jokes, it revealed something deeper than its creator expected. The image of the cat caught between life and death is more than a metaphor for quantum mechanics. It's a mirror for our own existence, for the way possibilities coexist inside us until the moment we act. Schrödinger's equation, that soft curve describing the motion of possibilities, doesn't care about cats or boxes or observers. It simply flows forward, predicting how the wave of potential will evolve. Left alone, it never collapses. The wave keeps spreading, like a melody that never ends. Only when we interfere, when we measure, when we ask the universe a direct question, does the wave fall silent, resolving into a single answer. Some physicists began to wonder, what if the collapse never truly happens? What if every note of the song continues to play, each in its own world, each unaware of the others? That question would become the heart of the many worlds interpretation, but in Schrödinger's time, it was still a whisper. For him, the paradox of the cat wasn't proof that both outcomes existed. It was proof that our description of reality was incomplete. The problem wasn't the cat or the atom. It was the assumption that one single version of reality must be true. The quantum world didn't seem to obey that rule, and perhaps neither did we. Even so, Schrödinger's story lingered because it captured something universal. We all live with invisible boxes, choices unopened, possibilities half-made, lives that could still unfold. Every decision we postpone, every chance we don't take, leaves a small version of ourselves suspended between worlds. In that sense, we are all Schrödinger's cat, resting in a superposition of dreams, waiting for the moment we choose which life to live. The beauty of quantum physics is that it doesn't just describe particles, it describes a philosophy of being. It tells us that uncertainty isn't failure, it's a natural state of the universe. Every atom, every photon, every heartbeat carries within it a spectrum of maybes. And when we finally decide, we aren't destroying the others. We're simply moving along one path while the rest drifts softly beyond our reach. That thought can sound unsettling, but it can also feel like grace. It means that nothing is ever truly lost. Every possibility, every might have been, still exists somewhere, woven into the quiet fabric of creation. The universe is vast enough to hold them all. Every note, every life, every cat, alive and otherwise. If you close your eyes for a moment, you can almost picture it. A sea of boxes, uncountable, stretching into infinity. Inside each one, a story waiting to be seen. Somewhere, a cat is alive. Somewhere, it isn't. Somewhere, you made that phone call or took that leap or stayed one more hour. The multiverse, if it exists, is not a science fiction fantasy. It's a map of everything that could ever be. A library of unopened boxes. And as we drift further into the story, we'll meet the man who dared to say that every one of those boxes is real. To him, the cat never needed to be saved or lost. Both outcomes exist, not in imagination, but in reality, spread across a limitless field of parallel worlds. His name was Hugh Everett, and his idea would change not just physics, but the way we think about ourselves. If we follow the river of thought a little further, we meet a young physicist who stood quietly at the edge of his generation's understanding and dared to say, what if nothing ever truly disappears? His name was Hugh Everett III. He wasn't a prophet or a rebel in the dramatic sense, just a curious student with a calm voice and a habit of questioning what others accepted as truth. But his question would ripple across time, changing the way we think about everything. In the middle of the 1950s, the world of physics was still glowing with the strange light of quantum mechanics. The Copenhagen interpretation, the idea that reality collapses when observed, had become the accepted wisdom. It said that the universe exists as a wave of possibilities until someone looks, and that observation narrows the wave into one solid outcome. The other possibilities simply vanish, like soap bubbles bursting in the sun. Everett didn't believe that. He thought the idea of things just disappearing felt unnatural. If the mathematics of quantum physics were correct, then the equation that described reality, that smooth wave of probabilities, should continue to evolve without interruption. It shouldn't suddenly stop just because someone happened to look. The universe, he believed, doesn't need an observer to exist. It already is. He began to imagine something new, a universe that doesn't collapse but divides. Each time an event happens that could have more than one outcome, reality doesn't choose. It multiplies. Every possibility becomes real, but in its own branch of existence. In one world, the cat lives. In another, it doesn't. Both outcomes unfold, but each in its own quiet universe, unaware of the other. There is no destruction, only division, like a river parting around a rock and flowing onward in two separate streams. Everett's idea was radical, but also strangely peaceful. It didn't deny the mathematics that others had worked so hard to build. It simply removed the need for the universe to pick favourites. All things that can happen, do happen, each within its own version of reality. And while each branch feels solid and complete to those who live inside it, the others continue just beyond our reach, silent as stars behind fog. He called it the relative state formulation, though later it became known as the many worlds interpretation. To Everett, it wasn't fantasy. It was the simplest way to preserve the logic of quantum theory without adding a mysterious collapse. The equations, he said, never break. They only branch. But if there are infinite versions of the universe, why don't we feel them? Why don't we sense the others drifting beside us? The answer lies in something Everett couldn't yet name, but that later physicists would call decoherence. Imagine a song splitting into two harmonies. At first, they share the same melody, vibrating together. But as time goes on, they drift apart. The notes no longer aligned. Each becomes its own music, complete but separate. In the same way, the branches of the universe diverge. They lose coherence, their rhythms falling out of sync. Once divided, they can no longer hear each other's echoes. Decoherence doesn't destroy the other worlds. It simply makes them unreachable, each sealed in its own harmony. And because every observer is part of the same process, we never notice the branching itself. To us, it feels like one continuous story. We don't remember the moments we split. We only remember the path we're still walking. For years, Everett's idea was dismissed. His professors were polite but skeptical. The great physicist Niels Bohr, who had helped define the Copenhagen view, read Everett's work and shook his head. The mathematics is elegant, he said, but the idea is unnecessary. To the scientific community of the time, many worlds sounded like science fiction, an infinite extravagance of realities, untestable and strange. Everett eventually left academia, working quietly as a defense researcher, living a life as ordinary as his theory was extraordinary. Yet, as time passed, the world began to catch up. Physicists studying quantum information and computing found that Everett's branching universe offered elegant explanations for puzzles that had long haunted them. It suggested that quantum mechanics might not be random at all, merely complete. The dice of the universe never choose. They simply roll in every possible way, each outcome forming a separate world where that version of chance becomes truth. There's a soft beauty in that thought. It means that nothing is ever truly lost. Every path that could have been taken still exists, just beyond sight. Every possibility has its place. Like pages in an endless book, you live on one page, reading your line, unaware of the countless others where your story took a different turn. Everett's life remained quiet. He never saw his theory gain recognition in his own lifetime. When he died in 1982, only a few physicists still remembered his paper. But after his passing, his work began to glow with a strange new relevance. The rise of quantum computing, machines built to exploit superposition and entanglement, made his ideas feel prophetic. Suddenly, the notion of parallel processing across branches didn't seem absurd at all. It became a practical vision of how nature might think. Today, His many worlds interpretation is not something that can be proven or disproven, at least not yet, but it continues to inspire, to stretch the boundaries of imagination, to comfort those who wonder about the roads they didn't take. Everett gave us a universe that doesn't waste potential. In his version of reality, every moment is a seed that blooms in infinite directions. Each possibility gets its own world, its own sunrise, its own heartbeat. Nothing is erased, only multiplied. And maybe that's why the idea endures. It doesn't just describe physics, it describes something deeply human. Our longing to believe that every version of ourselves, every forgotten dream still lives somewhere. That the world we didn't choose is still unfolding in a parallel dawn under a sky just like this one. As we drift further into the story, we'll pause to look at one of those mirrors Everett left behind. If all these branches exist, if every version of us continues somewhere, then what does you really mean? If you are multiplied across worlds, what happens to identity, to choice, to meaning itself? Let's step softly into that question, into the quiet paradox of being both the observer and the observed. If we follow the path Everett opened for us, the air begins to feel a little thinner, not because the world has grown smaller, but because our place in it has grown less certain. The question is no longer how many universes exist, but which one belongs to you. If every version of you exists somewhere, walking through their own mornings, making their own choices, who exactly is the you listening to this story now? It's an unsettling thought, but a beautiful one too. Everett's many worlds interpretation says that every possible outcome of every event is realised. Every decision you make, and even those you didn't, splits reality into separate branches. Each branch contains a version of you who followed that path. Some are very close to this one, maybe only a breath apart. Others are wildly different, like reflections in a shattered mirror. Each world is as real as the next, but they cannot see each other. They move forward, side by side, like rivers running through fog, parallel, endless and unaware. If you think of life as a coin toss, you could imagine each flip creating two universes. In one, the coin lands heads, in the other, tails. In both, there's a version of you watching, believing this outcome is the only one. But the universe, Everett said, doesn't discard possibilities, it keeps them all. To us that might sound extravagant, as though the cosmos were spending infinite energy to preserve every trivial event. Yet in the strange language of quantum physics, this is not wasteful. It's efficient. The equation describing reality doesn't need to choose between heads and tails. It simply contains both, flowing onward with each branch becoming its own melody. Physicists sometimes describe this process in terms of probability amplitudes, a phrase that sounds cold but hides something deeply poetic. Imagine a vast field of waves, each representing a possible state of the world. Where the waves overlap and resonate, a certain outcome becomes more likely, not certain, but favoured. Where they cancel each other out, the outcome becomes quiet, fading from the stage. When we observe, when we finally look, the universe seems to select one melody to play for us, but the others never stop existing. They simply play in a frequency we can no longer hear. That perhaps is what chance really means, not randomness, but limitation. The roll of a die doesn't create fate, it reveals the path we happen to be aware of. All 6 outcomes unfold, but we only experience one. Chance, then, is the narrow slit through which infinite possibility filters into consciousness. We call it luck because we can only see one pattern at a time. This brings us back to the quiet paradox at the centre of everything. If all versions of you exist, then what makes you uniquely you? The you sitting here, listening, breathing, existing in this branch of the universe. Maybe the answer lies not in the world, but in awareness itself. Each version of you contains its own thread of experience, its own heartbeat, its own flow of thought. That thread is what we call consciousness. It doesn't belong to the universe. It creates the universe you perceive. Each observer defines the world by witnessing it, by being aware of it. You are both the mirror and the reflection. The philosopher William James once wrote that consciousness is not a thing, but a process, the act of knowing itself. In quantum terms, you might think of it as the gentle collapse of possibilities into experience. Before you notice, there are countless versions of the moment waiting to unfold. Once you notice, one becomes real. That doesn't destroy the others. It just means your awareness is riding one particular wave among many. There's a soft kind of comfort in that idea. It means that your choices still matter, maybe even more than ever. You can't change what happens in other branches, but you can shape the one you inhabit. You can't jump between worlds, but you can make this one worth living in. The other versions of you, the ones who turned left instead of right, who spoke instead of stayed silent, are not lost or wrong. They are simply distant echoes, living their own truths beyond your horizon. Perhaps in some quiet way, we can still feel them. The subtle déjà vu that brushes against your thoughts, the dream that feels too real, the moment when you sense you've been here before. Maybe those are the soft vibrations of nearby worlds, still resonating faintly through the walls of reality. Science can't measure them, but the heart recognizes the feeling. It's the strange nostalgia for lives you never lived. Everett's idea forces us to look at identity as something fluid rather than fixed. You're not a single story. You're a collection of overlapping melodies. Each note plays somewhere, endlessly. You're both the singer and the song, the listener and the echo. The you that wonders about other versions is already proof of how large the self can be. Large enough to hold the entire multiverse within one heartbeat. And yet, despite all this infinity, life remains profoundly simple in its experience. You still wake up, make breakfast, watch sunlight move across the wall. You still choose one door, one word, one path. The other versions of you are not burdens to carry. They are reminders that existence is rich beyond comprehension. When you stand at a crossroads and hesitate, it's not just indecision, it's the universe pausing with you, holding its breath before it branches again. In a way, this is what the many worlds interpretation really means. It isn't an explosion of chaos, but a quiet affirmation that every possibility is valid. It tells us that the cosmos is generous, that it makes room for everything, even contradictions. And in that generosity we find meaning. We don't need to visit the other worlds to know they exist. It's enough to live this one fully, to treat every moment as the version of reality we've been entrusted with. As our quiet exploration now rises outward again, we'll leave the inner landscapes of thought and step back toward the grand machinery of the cosmos, the experiments and instruments that try to test these ideas. Beneath mountains and fields, enormous rings of magnets and metal hum in the dark, accelerating particles to near the speed of light. Their purpose is simple yet profound: to listen for echoes, to see if the invisible branches Everett imagined might leave a trace we can measure. As our quiet journey now turns outward again, the view widens from the invisible thoughts of consciousness to the immense, humming machinery of modern physics. Deep beneath the green fields of Switzerland, there lies a perfect circle cut into the earth, a ring so vast it could surround a small city, yet buried so deep that most people who walk above it never know it's there. This is CERN, the European Organisation for Nuclear Research, home to the Large Hadron Collider, the most powerful scientific instrument humanity has ever built. It's a machine that doesn't look at the stars but into the heart of matter itself. Its purpose is to listen for whispers, faint echoes that might reveal hidden dimensions and perhaps the traces of other worlds. The collider is like a vast underground racetrack. Instead of cars, it accelerates tiny particles, protons, the positively charged building blocks of atoms, until they race around the 27-kilometre ring at nearly the speed of light. Two beams are set to collide head-on, each containing billions of particles, their paths guided by powerful magnets cooled to temperatures colder than outer space. When they meet, the energy released is so great that it briefly recreates the conditions of the early universe, a fraction of a second after the Big Bang. And in that moment, scientists watch closely, waiting to see what reality will reveal. The collisions don't make fireworks, they make data, showers of invisible fragments that fan out like cosmic confetti. Detectors layered with sensors record their movements, searching for patterns that hint at something new. Among those patterns, physicists are hunting for something elusive, almost mythical. The graviton, a hypothetical particle that might carry the force of gravity. If it exists, it could explain one of the oldest mysteries in science. Why gravity, the force that shapes galaxies and holds the planets in orbit, is so much weaker than the other fundamental forces. The numbers are staggering. The electromagnetic force that binds atoms together is roughly a trillion times stronger than gravity. Why? Some scientists believe the answer might lie in extra dimensions. Perhaps gravity isn't weak at all. Perhaps it only seems that way because most of its strength leaks into other layers of reality we cannot see. Like water trickling through cracks in stone, gravity might flow freely between dimensions, linking our world to others just beyond perception. This idea is part of a family of theories that try to weave all the forces of nature into one grand framework. One of them, string theory, suggests that every particle is actually a tiny vibrating strand, so small that even the most powerful microscopes could never detect it directly. Each vibration gives rise to a different kind of particle, much like the strings of a violin producing different notes. In this picture, reality itself is a symphony of unseen vibrations. Some of those strings may extend into higher dimensions, curled up tightly like secret corridors in the fabric of space. If those hidden dimensions are real, the collider might one day catch a glimpse of them. A faint deviation in the motion of particles, a missing flicker of energy, a clue that space is deeper than it appears. Physicists also search for tiny black holes, microscopic pinholes in space-time that could form when particles collide at high energies. If such holes appeared, even for a heartbeat, they could show that gravity can bend reality enough to touch another dimension. These black holes wouldn't be dangerous. They'd vanish almost instantly, evaporating in a shimmer of light and heat. But their brief existence would be enough to prove something extraordinary, that our universe is not sealed, that other layers of existence might lie just beyond the thin curtain of what we call reality. It's easy to imagine all this as cold machinery and complex formulas, but when you stand in front of the collider, even through a screen, there's a feeling that rises above the science. The curved tunnels, the endless cables, the humming magnets, they all carry a kind of reverence. This is humanity's cathedral of curiosity, built not to worship but to understand. The scientists working there don't speak of miracles, but they chase something that feels very close to wonder, a whisper from the unseen. Sometimes they describe the search for the graviton as listening for tremors in nothing. The detectors are so sensitive that they can measure movements smaller than the width of an atom. They're trying to catch a faint vibration, the ghost of a particle that might flicker into our world and slip away again, a messenger from the space between universes. Each time a collision happens, billions of times a second, they hold their breath, hoping to find the soft footprint of something beyond the known. So far, no graviton has revealed itself. No tiny black hole has danced across their screens. The data remains silent. The universe, if it's hiding other layers, keeps them tucked away. But silence is not emptiness, it's potential. The fact that these searches continue, that we keep looking, is itself a kind of faith. Not the blind kind, but the patient one. The belief that the universe, given enough attention, will eventually speak. And even if it never does, the search is its own reward. To build a machine that can split atoms and catch glimpses of creation is to participate, however briefly, in the act of creation itself. The collider doesn't just smash particles, it reminds us that curiosity is the most powerful force we know. It turns the human need to ask why into something tangible, a beam of light circling the earth underground, humming like a heartbeat. So we stand at the edge of this experiment, watching, waiting, listening. Beneath our feet in the dark, particles race faster than thought, colliding with the force of imagination. Maybe one day they'll open a tiny door, a doorway not into destruction but into connection, a place where our universe touches the next. And even if that door remains closed, the idea of it, the whisper of hidden dimensions, is enough to remind us how vast and mysterious existence really is. As we follow this thread a little further, we'll rise from the tunnels below to the great cosmic canvas above, where faint traces of ancient light tell their own story. The universe carries scars from its earliest moments, and one of them, a cool bruise in the background glow of creation, might just be the mark of another world brushing against our own. From the tunnels below the Earth, our story now rises into the silence above it, into the ancient light that still drifts through space long after its source has vanished. That light is older than the stars, older than galaxies, older than memory itself. It is the echo of the universe's birth, a faint afterglow that fills every corner of the sky. To most of us, it's invisible, woven into the radio static between stations. But to astronomers, it's a kind of cosmic map, a ghostly photograph of the moment when the universe was only a few 100,000 years old. They call it the cosmic microwave background, or simply the CMB. You can think of it as the universe's baby picture, captured just after its first breath. When the cosmos was young, it was a storm of particles and light too dense for anything to escape. But as it expanded and cooled, light finally broke free, a soft radiation that began to travel outward, carrying the memory of that first dawn. Over billions of years, this ancient light has stretched and faded, cooling to just a few degrees above absolute zero. Yet it still surrounds us, a faint uniform glow that whispers the story of everything that ever was. If you could see it with your eyes, the sky would look like a tapestry of gentle colours, tiny ripples, no bigger than a few parts in 100,000, representing places where the early universe was slightly denser or cooler than average. These small irregularities were the seeds from which galaxies and stars would eventually grow. Every cluster of light in the night sky, every home, every heartbeat, can trace its ancestry back to those delicate ripples in the cosmic background. For the most part, the pattern is astonishingly smooth, like a perfect field of mist. But there is one place that breaks the harmony, a patch of sky, vast and silent, colder than it should be. Astronomers call it the cold spot. It spans an area hundreds of millions of light years across, an enormous region of the universe that seems to glow slightly less than the rest. When it was first discovered in 2004 by the Wilkinson Microwave Anisotropy Probe, scientists thought it might be an illusion, a quirk of data, or perhaps the shadow of an immense cosmic void, a region of space nearly empty of galaxies, where light stretches and cools as it travels through the sparse emptiness. But as observations improved, the mystery deepened. In 2017, new measurements suggested that the cold spot might not be explained by a void at all. There was something about it that didn't fit. It was too deep, too large, and too sharply defined. And so another, stranger possibility began to whisper through the halls of cosmology. Maybe that faint bruise in the sky isn't a void. Maybe it's a scar, a mark left from a collision long ago, when our universe brushed against another. It's a breathtaking idea that our cosmos in its infancy might have drifted close to another expanding bubble of space, Imagine two soap bubbles forming side by side in a sink full of foam. When they touch, the thin film between them trembles, and each bubble carries a faint memory of that encounter, a gentle dent in its surface. If universes form like that, in a grand cosmic froth, then the cold spot might be the faint dent left over from such a meeting, the place where two realities once shared a moment before parting forever. No one can prove it, of course. It's a theory woven from mathematics and imagination, a quiet bridge between the measurable and the mysterious. But there's a poetic symmetry to it. If the quantum world gives us branching universes that multiply with every decision, perhaps the cosmic world gives us universes that bump and blur, overlapping at the edges like colours in a watercolour painting. The very large and the very small might be playing the same game, each in its own way. The cosmos branching on a grand scale, the atoms branching on a tiny one. The music of infinity repeats its theme, just in different keys. To find patterns in the cold spot, scientists study temperature maps of the sky, made from satellites like Planck and WAP. The numbers may seem abstract, variations of millionths of a degree, but to a physicist they're as telling as fingerprints. They reveal how the universe expanded, how matter clumped together, and whether something unseen might have pressed against it. Each ripple is a syllable in the universe's first sentence. Reading them is like learning to hear an echo from the other side of eternity. Even if the cold spot turns out to have an ordinary explanation, a vast void, a statistical fluke, its story still humbles us. It reminds us that the cosmos is not smooth and uniform, but scarred and textured, full of mysteries that resist simplification. The sky, it seems, still carries the fingerprints of its creation, the wrinkles of a time when reality itself was still soft and forming. Sometimes, I like to think of the cold spot not as a flaw, but as a memory. The universe remembering a moment of contact. It's the kind of imperfection that makes something feel alive. Just as the lines on your palm tell the story of all the things you've held, maybe that dark patch in the sky is the trace of something the universe once touched and never forgot. And maybe that's the quiet lesson of this cosmic bruise. It tells us that our universe, for all its vastness, is not isolated. It might share a boundary with others, faint as the skin of a bubble, invisible but real. It might have siblings, cousins, reflections, other worlds expanding silently beside ours, each unaware, yet somehow part of the same breath. You could look at the cold spot as a clue or a comfort. A clue, because it hints that we are part of something larger, a multiverse of infinite beginnings. A comfort, because it suggests that even universes are not alone. They too collide, leave marks and move on. As we drift further into the story, we'll follow the trail of these cosmic fingerprints into one of the most alluring ideas of all, that there may be doorways through space itself. Not imaginary ones, but real passages written into the equations of gravity, bridges that could link not just distant corners of our universe, but perhaps one universe to another. They're called wormholes, and they may be the universe's quiet attempt to fold distance into something smaller, something almost within reach. If we follow the cosmic thread a little farther, the ripples of the early universe begin to fade into something even stranger. The idea that space itself can bend, stretch, and fold. And if it can fold far enough, perhaps it can touch itself, like paper meeting at its edges. That fold, that hidden bridge, is what we call a wormhole. A passage through space-time, linking two distant points, or maybe even two entirely different universes. It sounds like science fiction, but it was born from the same quiet equations that describe how apples fall and planets move. More than a century ago, Albert Einstein and his collaborator Nathan Rosen were studying how gravity warps the fabric of space and time. Their work led to what's now known as the Einstein-Rosen bridge, a mathematical structure that connects two regions of space through a kind of tunnel. Imagine a sphere of space being stretched until 2 points touch, forming a narrow throat between them. That throat is not empty, it's made of gravity itself, curved so steeply that light must follow the fold. It's as if the universe can take a shortcut through its own geometry. Gravity, in Einstein's language, isn't a force pulling things together the way a magnet pulls metal. It's the bending of space-time caused by mass and energy. The more massive something is, the more it curves the space around it. You can picture it like a heavy ball resting on a trampoline. The fabric dips under its weight, and smaller balls rolling nearby fall inward, not because they're being pulled, but because the surface itself tells them how to move. Black holes are the most extreme examples of this curve, places where gravity becomes so intense that not even light can escape the well it creates. A wormhole, in theory, is what happens when two of these curves connect, when the deep wells of gravity meet in the middle and form a bridge between them. Enter one side, and you could emerge from the other, light years away, or, depending on the shape of space-time, perhaps in another universe entirely. The math allows it. The question is whether nature does. Einstein himself believed such bridges might exist only for an instant. He thought they'd collapse before anything could pass through. But later generations of physicists began to ask, what if something could hold them open? Could there be a way to stabilize the throat of a wormhole long enough for matter, or even a traveller, to cross safely? That question led to some of the most fascinating and challenging ideas in modern physics. The equations that describe wormholes suggest that keeping one open would require a form of negative energy. In simple terms, that means energy that pulls instead of pushes, something that resists gravity rather than succumbing to it. Such energy isn't known to exist in macroscopic quantities, but quantum physics allows for tiny amounts of it to flicker in and out of reality. Some scientists think those fluctuations could, in theory, keep a wormhole from collapsing. It's an idea that feels both hopeful and impossible, like a dream the universe keeps rehearsing in secret. In recent years, theoretical physicists have published papers exploring how wormholes might behave if such energy were available. In 2021, one team even simulated a miniature version of a wormhole using quantum entanglement, not a real tunnel through space, but a model showing that the mathematics of quantum connections can mimic the way wormholes transmit information. It was like building a small echo of an impossible door just to prove that the melody exists. If a true wormhole ever could exist, crossing it would be unlike anything we can imagine. The gravitational gradients near its mouth would be immense. A traveller approaching the edge would feel a force pressing down, not gently, but with an acceleration many times stronger than gravity on Earth. A brief moment of 20 times your body's weight, scientists estimate, could be survivable if endured only for a heartbeat. But then there's time itself to consider. In the curved geometry of a wormhole, time can flow differently on each side. 1 second inside might equal centuries outside. You could leave your world, cross the bridge, and return to find that everything you loved has already turned to dust. It's a sobering thought. The idea that the universe might allow travel across its depths, but at the price of isolation. To move between worlds might mean stepping out of history altogether. The equations permit it. The heart hesitates. Even so, wormholes continue to haunt the imagination of scientists and dreamers alike. They represent a longing that has always lived within us. The desire to connect what seems unconnectable, to bridge not just space, but separation. The thought that two distant places could touch through a hidden fold is the ultimate expression of empathy written into the fabric of physics. It says that nothing is too far, not really. That distance itself is only another kind of illusion. If you could see a wormhole, not in a textbook but with your eyes, it might look like a sphere of shimmering distortion, a window into another sky. Around its edges, light would swirl, bending and looping as if drawn into a whirlpool. Inside, space would twist into a tunnel of glowing mist, narrowing and then opening again somewhere else. It wouldn't feel like falling. It would feel like stepping across a reflection. One moment here, the next somewhere else. as if the universe blinked and you followed the eyelid. For now, such doorways exist only in theory, in the quiet corridors of mathematics and imagination, but perhaps that's enough. The fact that the universe's own laws allow for something so miraculous tells us something about the nature of existence. Reality, it seems, is generous with possibilities. It leaves the door ajar even if we can't yet step through it. And maybe that's what we should take from these ideas. Not a promise of travel, but a lesson in humility. The same gravity that keeps us rooted to the earth also curves space into the shape of connection. It ties us, quite literally, to every other piece of matter in existence. Every atom in your body pulls on every star in the sky, and they pull back, however faintly. The entire universe is linked through that invisible tension. In a sense, you're already part of a cosmic bridge, one made not of metal or mathematics, but of gravity itself. As we drift onward through the story, we'll linger for a while with the impossible. If wormholes are the universe's open doors, then we must ask, what would it take to walk through one? What forces, what substances could keep that bridge stable? And what might we find waiting on the other side? If we follow the trail of gravity's imagination a little farther, the path leads us straight into the realm of the almost impossible. The dream of crossing from one end of the universe to another, through a tunnel made of space-time itself. Wormholes are the ultimate expression of that dream, and though they exist clearly within the equations of physics, reality has so far kept them sealed like folded letters never meant to be opened. Yet each new generation of scientists finds itself gazing at those sealed letters again, wondering if there might be a way to read them. In theory, a wormhole could connect two distant points in space as though they were side by side. It could also connect two different moments in time, or even two separate universes. The mathematics that describe them, born from Einstein's general theory of relativity, don't forbid their existence, but they whisper an uncomfortable truth. Nature seems to dislike shortcuts. Left to itself, space-time tries to close these tunnels almost as soon as they appear. The walls collapse inward, the throat pinches shut, and the bridge vanishes before anything can pass through. To keep a wormhole open, you'd need something extraordinary, a kind of material that doesn't behave like anything we've ever touched. Physicists call it exotic matter, but that name hides how peculiar it really is. Exotic matter would have negative energy density, which means it would push instead of pull. Ordinary energy, like sunlight or fire, radiates outward and adds weight to the universe. Negative energy would do the opposite. It would create tension in the fabric of space, pulling it taut rather than letting it sag under gravity's hand. In ordinary terms, you can think of it as the difference between a soap bubble and a rubber band. Gravity makes space act like a bubble, curving inward around mass. Negative energy would make it behave like a stretched band, resisting the curve, holding the tunnel open. But so far, negative energy is a concept more at home in the equations than in the laboratory. The closest we've come to observing anything like it is through the Casimir effect, a delicate phenomenon where two mirrors placed extremely close together in a vacuum experience a faint attraction caused by tiny fluctuations of quantum energy between them. The force is unimaginably small, weaker than the weight of a single feather resting on your hand, and yet it proves that even in what we call nothing, there is something, a restless hum that fills every inch of space. Some physicists think this quantum hum might, under the right conditions, be coaxed into behaving like negative energy. Not enough to build a wormhole you could step through, but enough to suggest that the idea isn't forbidden. The universe, it seems, enjoys keeping its doors locked but not welded shut. In 2022, a team of researchers managed to simulate a kind of wormhole on a quantum computer. Not a tunnel of space you could travel through, but a mathematical echo of how information might flow across entangled particles. In their experiment, data sent into one side appeared to re-emerge from the other, as if it had passed through an invisible corridor. It wasn't a real wormhole, of course, but it felt like a whisper of one. A digital dream built on equations rather than stars. The universe may not yet allow us to walk through these bridges, but we can at least model their shadows. If a stable wormhole ever could exist, crossing it would be both wondrous and disorienting. Imagine stepping into a tunnel where distance no longer behaves. You walk one step, and suddenly the stars rearrange. A second step, and you find yourself beneath a sky you've never seen. The journey might take seconds, but when you step out the other side, time itself may have shifted. Depending on the curvature of the tunnel, a few moments for you could equal centuries elsewhere. You might travel across the galaxy, only to find that the world you left behind has aged beyond recognition. That's the quiet tragedy written into every equation of interstellar dreams. The farther you go, the more you lose. The same relativity that bends space also bends time, stretching it unevenly across the fabric of motion. A second for one traveller can be a lifetime for another. The universe allows the crossing, but demands patience no living being could endure. Still, there's a reason we keep imagining it. The thought of wormholes taps into something older than physics, the human need to reach what is far away. We've always built bridges, between lands, between hearts, between ideas. To imagine one made of space-time itself is just an extension of that instinct, a cosmic continuation of every handshake and every letter ever sent across a distance. It says something tender about us, that even when faced with infinite separation, our first impulse is to connect. Maybe that's why, even as scientists debate the practical impossibility of such journeys, the metaphor endures. Wormholes represent hope disguised as geometry. They tell us that connection isn't just emotional, it's structural, woven into the way reality curves. Even when separated by impossible distances, the universe keeps folding inward, as if it, too, cannot bear to be apart from itself. There's another layer to this as well. Some modern theories suggest that the structure of space-time, the smooth continuum Einstein described, might actually emerge from networks of quantum entanglement. If that's true, then wormholes might not be exceptional bridges at all, but natural byproducts of the universe's deep connectivity. Every pair of entangled particles could be thought of as a microscopic wormhole, a thread stitching the cosmos together. The entire universe, seen from this angle, becomes a vast web of connections, every part linked to every other, in ways we're only beginning to understand. So maybe the dream of wormholes is not about building them, but about recognizing that we are already living within one, a universe that is itself a bridge between energy and emptiness, between matter and meaning. Every atom in your body has felt the pull of stars that no longer exist, and the light you see tonight began its journey before life ever began. In that sense, we've already travelled through time, through distance, through memory. The impossible journey is happening all the time, as our quiet exploration now turns from physics to philosophy, from wormholes to wonder. A new question begins to rise. If science keeps pointing toward connection between particles, between worlds, then why do we sometimes feel so separate? Why do we still dream of reaching across invisible walls? Maybe the next kind of bridge we build won't be made of equations, but of understanding, between minds, between realities, between versions of ourselves scattered across possibility. And perhaps, in the soft geometry of the multiverse, every time you reach out, with curiosity or kindness or longing, the universe folds a little closer, closing the distance it created just so we could learn what connection means. As our quiet journey drifts inward again, we move from the galaxies above to the constellations, inside your own mind, the shifting stars of memory. For all our searching in the sky, it's here, within the folds of the human brain, that some of the strangest multiverses may already exist. Not the cosmic kind, but the kind made of moments, where reality itself seems to bend, and something familiar suddenly feels not quite right. You've probably felt it before. You remember a logo that looks different now. You hum the ending of a song that somehow never ends the way you recall. You're certain that the Monopoly man wore a monocle, that the Berenstein Bears were spelled with an E, or that there once was a peanut butter called Jiffy. But when you look, the world insists you're mistaken. Every book cover, every package, every archive agrees on a version of history that feels wrong. That uneasy shiver, that moment of double vision between what you know and what is, that's what people now call the Mandela effect. The name comes from a curious story. For years, many people around the world shared a vivid memory that Nelson Mandela had died in prison in the 1980s, long before his actual passing in 2013. They remembered news broadcasts, morning crowds, even school lessons about his legacy. None of it ever happened. Yet the memory was so widespread, so collectively detailed, that it left psychologists scratching their heads and dreamers whispering about parallel realities. Science offers an explanation that is both ordinary and humbling. Memory, it turns out, isn't a recording device. It doesn't store perfect snapshots of the past, ready to replay on demand. Each time you recall an event, your brain reconstructs it from fragments. A few sensory details, a feeling, a framework of meaning. Then it fills in the gaps with imagination, association, and inference. Memory is less like a photograph and more like a painting that changes slightly each time you touch it. When we share stories with others, our memories blend. Cultural overlap and suggestion reshape them further. Over time, a false collective memory can form, a kind of cultural mirage. That's how the Mandela effect works. It isn't proof of parallel worlds, just proof that human minds are marvellously creative at making coherence out of fragments. And yet, there's something haunting about how convincing these false memories feel. It's not just forgetting, it's the sense of having been right, of recalling with absolute certainty something that never was. That certainty, that perfect emotional resonance, is what makes the mystery feel so real. Perhaps, on some level, it is real. Not in the physical sense, but in the emotional one. Memory doesn't store only facts, it stores feelings. The warmth of a summer afternoon, the smell of old books, the sound of a voice you loved. Those are as true as anything science can measure. If two versions of an event exist, one factual, one felt, which one is more real? Maybe both are, each in their own way. There's also a poetic possibility that tickles the edge of imagination. What if our minds occasionally brush against nearby realities? Not enough to cross into them, but enough to catch an echo. Maybe somewhere, in another branch of the multiverse, Jiffy peanut butter really did exist. Maybe the Monopoly man still adjusts his monocle before every turn. Maybe memory is the faint static left when two universes whisper through the same frequency. Science can't confirm it, but it doesn't need to. The beauty lies in the wondering. Neuroscientists describe memory as an electrochemical network. Pulses of electricity travelling through cells, strengthened or weakened each time they're recalled. But if you translate that into softer language, it becomes something quite beautiful. Your memories are constellations of light inside your brain. Each neuron that fires is a star, and together they form a shape, a pattern that tells the story of your life. When you remember, that constellation flickers to life again. But like stars in the sky, their positions shift ever so slightly over time. The pattern looks the same at first glance, yet no longer matches perfectly. The memory feels right, but not quite identical, like a familiar street with one lamp moved a little farther down. So perhaps what we call the Mandela effect is simply the cosmos of the mind realigning. A private universe readjusting its stars, reminding us that nothing stays perfectly fixed, not even the past. Still, the metaphor of parallel worlds feels irresistible, doesn't it? There's comfort in imagining that the memories we've lost still exist somewhere. The childhood house that was torn down, the version of yourself who never moved away, the friend you lost touch with. Maybe they're still walking their streets, still laughing in some neighbouring branch of reality. Maybe memory isn't a malfunction at all, but a kind of resonance, the echo of those other yous, those other times, still alive in the greater song of existence. If that's true, then perhaps forgetting is not failure but mercy. To remember everything exactly as it was would be unbearable. The mind softens the edges of time, blending details so we can carry the story without drowning in its precision. Memory gives us meaning, not accuracy, and in doing so, it becomes one of the most human forms of quantum uncertainty. Each recollection is a wave of possibilities collapsing into a single version of the past, one that feels whole, even if it's just one branch among many. And when you think about it that way, the mystery becomes a little less eerie and a little more tender. Our minds are not lying to us. They're trying to make sense of an ever-changing world. They store feelings first, facts second, because emotion is the language reality speaks to consciousness. Facts tell us what happened. Feelings tell us why it mattered. So the next time you find yourself certain that something has changed, a word, a colour, a memory, pause before you correct yourself. Smile at the possibility that maybe, just maybe, your mind caught a brief echo from another version of the world, not because it's proof of multiverses, but because it shows how vast your inner universe truly is. As we drift further into this gentle maze of memory and meaning, we'll meet a writer who once believed he'd glimpsed behind the curtain of reality itself, that our world is a kind of simulation, occasionally patched, like a cosmic computer program. For him, déjà vu wasn't an illusion, it was a sign that the universe had just been updated. His name was Philip K. Dick, and his story blurs the line between imagination and revelation, between science fiction and something that feels like truth. If we follow the echo of memory a little farther, we find ourselves stepping into the strange, flickering world of a man who believed reality itself could be edited, like a story rewritten between printings. His name was Philip K. Dick, and he wrote science fiction the way some people breathe, urgently, endlessly, as though he were trying to make sense of a dream that kept changing shape around him. For him, the multiverse wasn't an abstract theory, it was personal, something that whispered through his own life, sometimes so vividly that he could no longer tell which world was the real one. Philip K. Dick was born in Chicago in 1928, though he might have told you that his real birth was much later, sometime in 1974, when a beam of pink light, as he described it, flooded his living room and seemed to reveal the hidden gears of reality. He said that in that instant he saw through the surface of the world. Everything familiar, walls, furniture, time itself, felt like a fragile projection, and behind it, he sensed another version of existence humming softly, as if the universe was showing him its second draft. The experience changed him forever. From then on, he believed that our world was a kind of simulation, not in the digital sense we imagine today, but more like a dream the universe keeps revising as it learns. He began to describe déjà vu as a kind of patch in that dream, a moment when the cosmic software updates itself and we feel the echo of its rewrite. When the universe changes its mind, he said, we feel it as a glitch. He wrote about these ideas constantly, weaving them into his novels, stories that felt prophetic long before the world caught up. In Ubik, he imagined reality slowly disintegrating into older versions of itself, like a film reel playing backward. In The Man in the High Castle, he pictured an alternate history where the Allies lost the Second World War, a world so complete and convincing that, for a time, even he struggled to believe it wasn't true. Behind all these fictions was a single, aching question. What if the universe is alive, thinking, correcting, evolving, and we are the characters inside its ongoing draft? Dick believed that sometimes the program misfired. In those moments, people experience glitches, coincidences too perfect to ignore, forgotten memories returning at the exact right time, events repeating with slight variations. To him, these weren't mistakes but maintenance. The universe repairing itself in real time, and us, the observers, catching a brief glimpse of the process. To some, that might sound like madness. But when you read his letters and journals, you can feel the sincerity, even the pain behind his visions. He wasn't trying to escape reality. He was trying to reconcile it. He saw patterns in chaos, meaning in repetition, and perhaps that was his way of coping with a world that often felt unbearable. In the 1960s and 70s, he lived on the edge, financially struggling, often ill, surrounded by the noise of an accelerating world. It's no wonder he began to suspect that the machinery of reality was fraying. To live in uncertainty, he wrote, is to live in truth. Modern psychologists might call some of his experiences delusions or hallucinations, symptoms of exhaustion and stress. But even that doesn't take away their poetic power, because beneath the paranoia, his ideas contained something profoundly human, a longing for coherence, for reassurance that life isn't just a random drift of moments. Dick wanted to believe that behind all the chaos, there's an order that cares enough to correct itself, and maybe that's why so many readers still find solace in his stories. They remind us that confusion, fear, and beauty can coexist, that the line between imagination and truth is not a wall, but a doorway. In one of his essays, he described a vision of two overlapping worlds. In one, the ancient Roman Empire never fell. In the other, modern America continued as normal. He claimed to have seen both at once. Streets of California shimmering over cobblestones of Rome, citizens carrying groceries past temples. It sounds impossible, yet there's something dreamlike about it, something that mirrors the way our own memories overlap. Perhaps Dick wasn't so much seeing through time as through layers of consciousness, the way different possibilities coexist within the same space, waiting for attention to bring one into focus. Even today, scientists talk about the multiverse with a similar reverence. Infinite realities layered atop one another, invisible but adjacent. For Dick, this wasn't a theory to test. It was a truth to feel. He often said that reality is what doesn't go away when you stop believing in it. And yet, he spent his life challenging that very idea, daring to believe that even the unshakable could shift under the right light. There's a quiet sadness in his story too. He died in 1982, just before the release of Blade Runner, the film adaptation of his novel Do Androids Dream of Electric Sheep. He never saw how his visions of artificial life, memory implants, and shifting identity would define modern science fiction. Perhaps that's fitting. His work was always meant for the future, for readers not yet born who would one day live in a world where computers talk, where virtual realities exist, and where the line between the real and the simulated grows softer by the day. If you listen closely to Dick's philosophy, it's not really about paranoia or control. It's about tenderness, about the possibility that reality cares enough to be self-aware. Maybe the universe is, in its own way, alive. Maybe it learns from every thought, every story, every correction. Maybe consciousness is not a passenger inside the cosmos, but its author, revising, editing, dreaming the next draft together. And so, as we linger for a moment in the strange, flickering glow of his imagination, perhaps we can understand him not as a prophet of fear, but as a poet of possibility. He turned uncertainty into art, confusion into wonder. His stories remind us that it's okay not to know which world is real, as long as you keep looking with curiosity and kindness. As we follow this thread a little further, we'll leave behind the idea of rewriting reality and explore something even deeper, the nature of time itself. Some scientists and philosophers have wondered whether time flows at all, or if every moment already exists, quietly coexisting like pearls on an invisible string. If that's true, then perhaps we don't move through time. Time moves through us. as we drift onward from the world of stories and simulation, another mystery begins to surface, one older than science, yet still unsettled in the quiet halls of physics. It's the question of time itself. We talk about it as if it were a river, flowing from past to future, carrying us gently downstream. But what if time doesn't flow at all? What if everything, every heartbeat, every sunrise, every moment you've ever lived or will ever live, already exist together, side by side, like the colours in a painting? What if the current is not in the river, but in the way we see it? That idea has haunted philosophers for centuries, but in the last 100 years it has found strange allies among scientists. One of them was a Russian astrophysicist named Nikolai Kozyrev. He worked during the early and mid-20th century, a time when the universe seemed mechanical, predictable, ruled by equations like clockwork. But Kozyrev saw something different. He believed that time was not just a measurement, not a number printed on the face of a clock, but a real substance, a kind of energy that connects all things. He imagined it as an invisible ocean, and everything that exists, every star, every person, every thought, as bubbles rising through it, appearing and vanishing, but always part of the same sea. To Kozyrev, time wasn't a straight line, it was alive. He wrote that time carries information, that it remembers events, and can even reflect or echo them. Some of his experiments, though never proven, were deeply poetic in spirit. He claimed that mirrors shaped like spirals could concentrate the flow of time, like lenses bending light. Mainstream science never accepted his results, but his metaphors stayed because they captured something that mathematics alone could not. Modern physics too has begun to whisper similar ideas, though in more cautious language. When Einstein unified space and time into a single concept, space-time, he described it as a four-dimensional landscape. Past, present and future aren't separate points being created one after another. They're coordinates already woven into that landscape. You don't move through time. You move within it, tracing your path like a thread through fabric. Every moment already exists. It's just that your consciousness touches one bead at a time, giving the illusion of motion. If that sounds abstract, imagine a movie reel. The entire film, beginning, middle and end, exists at once, coiled and complete, but you only experience it as it passes through the projector frame by frame. To you, the story seems to unfold in sequence. To someone holding the reel, all the moments coexist in stillness. Perhaps the universe is like that, a grand film, already written, playing continuously in the theatre of awareness. You're both the actor and the audience, watching the script you help illuminate with your choices. In quantum theory, there's even a gentle echo of this idea. When we describe particles not as points but as waves, their behaviour isn't bound strictly by time. Some interpretations suggest that events in the future can influence outcomes in the present, as if cause and effect were threads woven both ways. It's not that the future reaches back to rewrite the past, it's that both are part of the same tapestry, existing together in a symmetry our minds find difficult to grasp. If we translate that softly, it becomes a simple but profound notion. Time might be less like an arrow and more like an ocean. You can drop a pebble in one place, and the ripples travel outward, but they also reflect inward, meeting ripples from other pebbles you haven't yet thrown. The pattern is continuous, without true beginning or end. That's why some physicists and philosophers now speak of a block universe, not because it's cold or rigid, but because it holds everything. Every moment, every possibility is part of a single, timeless structure. You don't pass through it, you unfold within it, like a flower opening petal by petal, even though the entire blossom already exists in potential. The act of living is the act of revealing what was already there. For most of us, though, this is hard to feel. we're creatures built to experience time as sequence, cause followed by effect, morning followed by night. The brain evolved to notice change, to mark duration, to measure the space between beats. We need the story to feel real. Without it, existence might seem static, even unbearable. So we live within the rhythm of linear time, even if the deeper truth hums beneath it, like a drone note we can sense but never isolate. Sometimes, though, the illusion flickers. A smell, a sound, or a déjà vu moment pulls us sideways, and suddenly the past feels close enough to touch. You might catch yourself thinking of a childhood afternoon, the sunlight falling exactly the same way it does now, and for an instant time folds. The years between then and now dissolve, and both moments coexist, layered like glass slides on a light table. Perhaps those are the small reminders that Kozyrev's ocean is real, that all the moments of your life are still here, suspended, waiting for consciousness to visit them again. The same could be true on the cosmic scale. If every moment of the universe already exists, then the Big Bang isn't a beginning. It's just one luminous point in the greater shape of eternity. The end of time, if such a thing exists, is another point in the same structure. We move from one to the other not because time flows, but because our awareness does. The present is a traveller, moving through an unmoving infinity. There's something peaceful about that idea. It means that nothing is ever truly lost. Every instant, every conversation, every kindness, every heartbeat still exists somewhere in that grand, motionless ocean. We don't need to chase it. We only need to remember that we are swimming in it all the time. Eternity, perhaps, isn't endless time at all. It's the gentle realization that everything is happening now, and always has been. As we drift toward the final part of this inner journey, we'll step out of the timeless and return to the human. We'll look at why we dream of the lives we didn't live, and how the longing for what could have been may not be a flaw, but a quiet tribute to how deeply we care about being alive at all. If we follow the tide of time back toward the heart, we arrive at a softer question, not about the structure of the universe, but about the structure of longing. Because even after all the theories, the equations, the maps of stars and atoms, there remains this simple ache within us. What if things had gone differently? What if I had stayed? What if I had left? What if that one moment, that one sentence, that one hesitation had turned the other way? It's such a small thought, yet it feels enormous. The imagination opens like a window, and suddenly there's another life glowing just beyond the glass. A version of you who took the train you missed, who said yes instead of no, who never said goodbye. You know it isn't real, yet your heart leans toward it all the same. That quiet pull, that invisible gravity between you and your other selves, is one of the gentlest proofs that human consciousness too knows how to branch. Psychologists call this habit counterfactual thinking, the mind's tendency to construct alternate versions of events, replaying moments and imagining new endings. It's not a flaw in our design, it's part of how we learn. Each what if is the mind's way of testing the boundaries of the possible, exploring the paths we didn't take so that we can understand the one we did. But when the imagination is too vivid, these unreal lives can feel heartbreakingly close. The door between the actual and the imagined becomes a thin veil, trembling in the wind. Perhaps that's why the multiverse resonates so deeply with us. It takes a psychological truth, that we all live surrounded by the ghosts of unrealized choices, and gives it cosmic permission. It says, maybe those choices did happen somewhere. Maybe the person you could have become didn't vanish when you chose differently. Maybe they just stepped sideways into another reality, another branch, another sunrise. You can't meet them, but you can sense them, like hearing a faint harmony next to your own melody. When you think of it this way, our minds are not just remembering and imagining, they are modelling multiverses. Every day your brain simulates possible futures. It plays through conversations that haven't happened, anticipates outcomes, weighs costs and rewards. This constant rehearsal of possibilities is how the brain survives. It's a kind of mental quantum mechanics, collapsing thousands of imagined worlds into one decision that becomes your lived reality. But longing complicates this process. It makes some of those imagined worlds too beautiful to let go of. We find ourselves haunted by the better version, the smoother path, the kinder self. Yet even those imagined lives would have carried their own storms, their own secret weights. Every version of you in every universe would still be human, imperfect, uncertain, endlessly reaching for meaning. The heart, it seems, would always find something to miss. There's a tender way to think about that. Maybe these alternate lives we imagine aren't illusions, but reflections. Mirrors held up by the mind to show us what we value most. When you daydream about another life, you're not trying to escape. You're trying to understand what matters deeply enough to dream for. The life you picture is the shape of your yearning, not a record of your mistakes. Sometimes it helps to imagine the self as a house with many rooms. Each room is a different version of who you could have been. Some are bright with laughter, some are quiet with solitude. Some you've walked through already. Others remain closed, their doors untested. You can visit them in thought, but you can't live in all of them at once. The architecture of the human mind allows for infinite possibilities, but the architecture of living gives you only one body, one timeline, one heartbeat to carry them through. That limitation isn't cruelty, it's grace. Without it, nothing would hold meaning. If you could live every life, you'd lose the preciousness of this one. The awareness that every moment could have been otherwise is what makes every moment matter. The universe, vast as it is, still needs focus to create beauty, and so do you. Neuroscientists sometimes describe imagination as the brain's default mode network, the quiet circuitry that lights up when you aren't focused on any specific task. When you drift, daydream, or replay the past, those regions of the brain hum softly, weaving threads between memory and prediction. If we translate that into gentler language, it means your mind never really stops creating. Even in stillness, it builds worlds. And maybe that's why, when you close your eyes, you can still feel the presence of other versions of yourself, not as ghosts, but as gentle possibilities, always near, always humming. The philosopher Kierkegaard once wrote that life must be lived forward, but understood backward. In the space between those two directions, imagination blooms. It's what lets us find meaning in what we've already chosen, and compassion for the selves we never became. To regret is to wish you could edit time, but to reflect is to realize that even the unchosen paths gave you shape, that the person you are now carries the faint fingerprints of all the others you might have been. So maybe longing for other lives isn't a flaw. Maybe it's a kind of gratitude in disguise, gratitude for how wide reality could be, even if you only ever touch one strand of it. When you feel that quiet ache, that what-if sigh before sleep, don't push it away. Let it rest beside you like an old friend. It's not asking you to change your life. It's reminding you that you are capable of imagining more than one. And that imagination too is a form of love. Because to dream of other lives is not to reject this one. It's to honour the mystery of being alive at all. To acknowledge that existence is generous enough to hold infinite versions of you, and still let one of them wake up each morning, breathe the air, and call this branch home. As we drift toward the final part of our journey, the story begins to fold back into itself. We'll look at how these small choices, every yes, every no, every pause, shape the world you live in. And perhaps by the end, we'll find that the butterfly effect is not just a scientific metaphor, but a gentle reminder that even the tiniest act of awareness can ripple across eternity. If we follow the quiet pulse of the story back into the wider world, we begin to see how all these invisible possibilities, the unchosen paths, the near misses, the gentle what-ifs, are not just private fantasies. They are the texture of history itself, Every moment, every movement, every heartbeat has the power to shift the course of things in ways that no one can predict. The universe, it seems, doesn't need grand gestures to change direction. It just needs a butterfly. The idea comes from meteorologist Edward Lorenz, who, in the 1960s, discovered something astonishing while studying weather patterns. He had built one of the earliest computer models to simulate storms, feeding in equations that described how airflows and temperatures mix. One afternoon, he decided to rerun an earlier sequence but rounded one number slightly, a difference smaller than the flap of a gnat's wing. To his surprise, the result was completely different. Instead of repeating the same storm, the model produced an entirely new weather system. A minute change in starting conditions had rewritten the entire future of the simulation. From that moment came the poetic phrase, "A butterfly flaps its wings in Brazil, and somewhere a tornado begins in Texas." Of course, Lorenz didn't mean it literally. No insect is responsible for hurricanes. What he meant is that in complex systems, the weather, ecosystems, even human lives, small events can amplify through feedback loops until they become vast outcomes. It's called sensitive dependence on initial conditions, but we can translate that into something gentler. Every beginning carries echoes that stretch farther than we can see. You don't need to understand chaos theory to feel it. Think about the moments that quietly redirected your own life. A phone call you almost didn't answer, a train you nearly missed, a sentence you spoke without thinking. Each small turn of timing cascaded through the years like falling dominoes, touching people you never met and shaping futures you'll never witness. In that sense, the butterfly effect isn't just a metaphor for weather. It's a portrait of existence itself, delicate, unpredictable, and endlessly intertwined. History is full of such moments. A single, missed connection between two travellers can mean generations of difference. A letter arriving one day late can avert or ignite wars. A random decision to take shelter under a certain tree might, in another timeline, have changed who lives and who doesn't. The universe is stitched together with coincidences so fine we rarely notice them until we pull one thread and feel the whole pattern tremble. Even the grandest events began with something tiny. The asteroid that ended the reign of dinosaurs 66 million years ago was just one rock among billions orbiting the Sun. If its path had shifted by a few minutes, if another small stone had nudged it differently, mammals might never have risen, and you might not be here at all, listening in the quiet tonight. The smallest timings, multiplied across deep time, are what built the stage we stand on, and the same pattern plays out at the human scale. A couple meets because one decided to attend a concert at the last moment. A scientist makes a discovery because a colleague left notes on the wrong desk. A friendship begins because someone dropped a book in the right cafe. These are not accidents. They are the way the universe composes its music, improvising through coincidence, turning chaos into melody. Sometimes the butterfly effect feels cruel, as when a minor decision leads to regret. But even those moments, seen from a longer distance, often reveal a strange symmetry. The painful detours, the delays, the missed opportunities, each redirects the current of our lives in ways that later form unexpected blessings. It's as if the universe, through 1,000 small adjustments, keeps tuning us toward the next note in the song. There's humour hidden in this too. Imagine how many enormous consequences began with something as trivial as a menu choice or a sneeze. Perhaps a great-great-grandparent once stopped to tie a shoe, delaying a meeting by a minute. And that single pause became the difference between whole bloodlines existing or not. The universe loves such ironies. It builds entire worlds out of tiny hesitations. Physics too echoes this sensitivity. At the quantum scale, the fate of a particle depends on unimaginably subtle interactions. A nudge here, a collision there, a probability collapsing one way instead of another. If we translate the mathematics into feeling, it says this: the smallest motion has weight. The universe listens even to whispers. When you stand in line at a cafe or pause before crossing the street, you're not just passing time. You're participating in the choreography of infinite consequences. The person behind you might overhear a phrase that sparks an idea that changes their life. The driver waiting at the light might catch a moment of reflection that alters how they speak to their child that night. None of us can see these chains as they unfold, but they happen constantly. Billions of invisible ripples weaving the future together. It's humbling, isn't it? We spend our lives chasing the big moments, promotions, breakthroughs, revelations, yet the fabric of reality is held together by moments so small we almost overlook them. The universe doesn't seem to rank importance the way we do. To it, a butterfly's wing and a supernova are just two expressions of motion. Scale is a matter of perspective, not value. Maybe that's why kindness, though simple, feels so profound. A smile, a gentle word, a small act of patience. Each is a microcause in the vast web of consequences. You'll never know how far it travels, but that doesn't matter. In a universe built on sensitivity, gentleness is a force more powerful than we imagine. So, when you think of your own life, try to see it not as a straight road, but as a field of ripples. Every breath, every choice, every pause sends a wave outward, touching the unseen. You are the butterfly and the storm, the question and the answer, all at once. As we drift a little farther into the story, we'll follow this idea to its quiet heart, to the way our choices echo through reality, shaping not only the world around us, but the branch of existence we call home. We'll see how every yes and every no, however small, helps the universe decide which melody to play next. If we follow the flutter of that butterfly's wings a little longer, we begin to hear something softer beneath it, the sound of echoes. Every action, no matter how small, sends one out. Some fade instantly, others linger, folding back into our lives months or years later disguised as coincidence. But whether you notice them or not, they're always there. The quiet reverberations of everything you've ever done, still rippling through the invisible fabric of cause and effect. Physics tells us that no event is ever truly isolated. In the language of energy, every motion transfers something, a vibration, a pattern, a small disturbance that never quite disappears. Even in a vacuum, the faint hum of quantum fields ensures that nothing is ever perfectly still. The universe, if you listen closely enough, is an orchestra that never stops playing. Each of us is a single instrument, but together we compose the melody of existence. And yet, despite knowing this, we often treat our choices as if they end with us. We imagine each decision closing behind us like a door. But the truth is gentler and stranger. Choices don't close, they expand. They branch outward like rivers, forming tributaries of consequence that stretch far beyond our sight. Every yes, every no, every maybe later changes the shape of the future just a little. It's easy to underestimate the power of a word, a glance, a moment of silence, but those are the hinges upon which entire lives can turn. Think of the last time you said something kind without planning to. You might not remember it now, but maybe the person you spoke to still does. Maybe it changed how they treated someone else later that day. Maybe that second person carried the kindness farther, passing it like a torch into someone else's darkness. Somewhere down the line, that single spark, yours, might be keeping a stranger warm tonight. And all you did was speak a sentence. Or think of the opposite. The time you let irritation slip into your voice, or turned away too quickly, or forgot to listen. Those moments echo too. But not as punishment, only as gentle reminders that energy is always moving. The world remembers every tone you give it, every vibration you send into its web. Even regret is part of that remembering, a sign that we are attuned to the way our choices resonate. In quantum mechanics, there's a phrase that describes something similar: entanglement. When two particles interact, They can become linked in such a way that their states remain connected, even across great distances. If one changes, the other responds instantly, as if distance were just a suggestion. It's as though the universe itself refuses to forget that they once touched. If we translate that into our own language, it might mean this: everything that connects us leaves a trace. Every shared moment, every friendship, every act of care creates a kind of human entanglement. Long after the moment passes, we continue to move in quiet sympathy with those we've met, subtly influencing each other in ways we'll never fully see. Maybe that's why so many of our choices feel heavier than their size. Why we sometimes wake at night replaying a conversation or wondering how things might have gone differently. It isn't just guilt or nostalgia, it's the echo of energy seeking resolution. The universe is endlessly self-correcting, finding balance the way water finds level ground. Your smallest actions are threads in that larger equilibrium, one tug here, one loosening there, all part of a greater harmony we never stop weaving. But there's comfort in that too, because if every action has an echo, then redemption always exists. A harsh word can be balanced by gentleness tomorrow. A mistake can be softened by an apology. The same sensitivity that makes our choices powerful also makes healing possible. Every moment is a new chance to send out a softer sound. It can help to imagine your life as a garden, one that grows according to where you place your attention. Each thought and action is a seed. Some sprout quickly, some take years to bloom, some never break the soil but nourish it invisibly beneath. You're both the gardener and the ground, shaping and being shaped at the same time. The universe provides the weather, storms, sunlight, seasons, but what grows is your doing. The metaphor is simple, but the science aligns with it more than you might expect. In neuroscience, studies show that repeated action strengthens pathways in the brain. It's called neuroplasticity, the mind's ability to reshape itself through practice and attention. What you focus on grows stronger, what you neglect fades. It's a biological echo of the same truth. Where you invest energy, the universe responds. So each time you choose to forgive, to listen, to act with patience, you're not just changing your mood, you're reshaping your inner world, one connection at a time. You're tuning your instrument to the larger song. But here's the paradox Everett's many worlds theory reminds us of. Every choice you don't make still exists somewhere. Each alternate path continues, unaware of you, complete in its own way. The you who took that other job, that other road, that other leap, they live on in their own timeline, and maybe they too wonder about you. You can't reach them, but you can honour them by living this version fully. Think of it as the physics of meaning. There may be infinite branches, but only the one you inhabit can bloom beneath your hands. The others are like faint harmonies, real but out of reach. What gives this branch value is your attention to it. The act of noticing, of caring, collapses the infinite into the particular. That is how the universe becomes personal. That is how something vast becomes yours. So when you stand before a choice, large or small, remember that the future isn't waiting for perfection, it's waiting for participation. The universe doesn't ask you to be flawless, it asks you to be awake. Every yes is a ripple, every no is a shape carved in the current. What matters most isn't the size of the action, but the presence behind it. As our journey continues, we'll follow that presence into one final reflection, the responsibility of being real. If all worlds exist, if every version of you is out there somewhere, then what gives this version meaning? Perhaps it's that you are here in this moment, aware enough to choose kindness, to listen, to let your small echoes travel farther than you'll ever know. If we follow those echoes a little further, they begin to form a pattern, a quiet realization that what we do, even in our smallest moments, has weight. Not the heavy kind that bends our shoulders, but the kind that bends reality itself just a little. It brings us to one of the most intimate questions the multiverse has ever offered. If every version of you exists somewhere, does that make your choices meaningless or infinitely meaningful? At first, it sounds like a paradox. If every outcome happens, then what's the point of choosing at all? In one world you turn left, in another you turn right. Somewhere you succeed, somewhere you fail. Every coin flip is both heads and tails, somewhere in the grand branching of reality. But here's the soft secret that physics can't quite put into equations. Meaning doesn't live in the outcome, it lives in awareness. In the simple act of being conscious, of noticing, of caring about which version of the world you create. You could think of it as quantum responsibility. In the equations of quantum theory, the act of observation changes the system. A pattern that was a blur becomes a point. A wave of potential becomes an event. That doesn't mean we control the universe, but it suggests that attention itself participates in creation. Every time you choose to look with kindness or patience or curiosity, you help reality take that shape. Your focus is a small gravitational field, invisible but real. In the physical sense, gravity bends space and time, curving the paths of stars and light. In the same way, our choices curve the path of experience. Every thought is a small bend in the geometry of your world. Attention gives weight to what it touches. It's why gratitude feels grounding and worry feels heavy. The mind is reshaping its landscape with every emotion. You are quite literally the sculptor of your perception, carving meaning into the smooth stone of possibility. When Everett spoke of his many worlds, he never meant that we could travel between them. He meant that all outcomes exist, but our awareness walks only one path. So even if countless versions of you are out there, only this one, the one who listens now, who breathes and thinks and wonders, has the gift of choice in this thread of time. You can't change what happens in the others, but you can shape this one with intention. You can make it gentler, deeper, more alive. Perhaps that's what consciousness really is. The universe paying attention to itself. Each of us a tiny lens focusing infinity into a single point of view. You don't have to understand the mathematics to feel it. Every time you pause before reacting, every time you notice beauty, every time you forgive, you're participating in the unfolding of reality. Awareness isn't just a passenger in the cosmos, it's part of the machinery that keeps it alive. You might wonder, if we can't see the other worlds, do they matter? Maybe not to us directly, but their existence gives perspective. It reminds us that this life, this one heartbeat in the endless choir, is precious precisely because it's finite. If you had infinite chances to make every choice again, you might stop cherishing any of them. The mystery of existence is not that it repeats, but that we experience it as unique. The awareness that this moment will never return is what makes it glow. In physics, there's a gentle idea called decoherence. It explains how different branches of the quantum world drift apart and lose connection. Once separated, they can no longer exchange information. You might think of it as the universe ensuring that each reality can live its own story. It's a way of keeping the music from blending into noise. In a similar way, your attention decoheres the infinite. It allows one melody, your life, to stand out against the background hum of possibility. And like any good melody, it's shaped not by perfection, but by rhythm, by pauses, by imperfection made graceful. Responsibility, then, isn't about control. It's about participation. You don't have to move mountains. You just have to be here, listening, choosing where to place your small gravity of attention. If every thought is a seed, plant the ones that make your world bloom. If every action is an echo, let it be one worth hearing again. The scale doesn't matter. In a universe where everything connects, no act of care is ever wasted. There's a quiet power in that realization. It means that even in uncertainty, you still have purpose. You can't predict how your choices ripple outward, but you can choose their direction. A single act of compassion can cross more boundaries than light. A simple moment of awareness, of truly seeing another person, can collapse 1,000 possibilities into one small miracle of understanding. That's what responsibility looks like in the multiverse. Not control, but contribution. And maybe, in a way, that's what the universe has been trying to teach us all along. From the flutter of a butterfly's wings to the orbits of galaxies, everything participates. Nothing stands apart. You don't have to know the equations to feel it in your bones. Every atom in your body is made of recycled starlight. Every breath you take changes the balance of the air that feeds another life. You're already entangled with everything, already part of the vast experiment of being. So when you think of the other versions of yourself, the ones who chose differently, who live other lives, don't let it make you small. Let it make you generous. Somewhere, another you is learning patience, another is learning courage, another is learning to forgive. All of them are teaching this version of you in ways too subtle to measure. You don't need to fix the other worlds. You only need to tend to this one, knowing that in some quiet way your peace ripples outward to them all. Perhaps that's the truest kind of responsibility. To live with awareness, not anxiety. To understand that even the smallest act of presence is a form of creation. To wake each morning and treat this branch of the universe not as random, but as chosen. Because in the end, maybe that's what consciousness does best. It turns possibility into meaning, and chaos into care. As we drift gently toward the close of our journey, we'll gather all these threads, choice, chance, awareness, and wonder, and weave them into a final reflection. A lullaby for the self you are right now, and for all the selves you'll never meet. Because even if you can't visit your other lives, you can still make peace with them, by living this one as though it were the only universe that ever needed to exist. And so, we arrive at the quiet edge of everything, the place where questions fade and only the soft hum of existence remains. After all the branching theories and cosmic possibilities, after the whispers of other worlds and other selves, what's left is something simple, the life you're living right now. The one made of small mornings, familiar faces, half-remembered dreams, and choices that once felt ordinary but turned out to be everything. If there are infinite versions of you, scattered across the folds of the multiverse, then each one is a reflection, a facet of the same diamond catching light from a different angle. You might imagine them all standing side by side, each living a slightly altered rhythm, each learning something you'll never know. Somewhere, one of them is standing at a window, thinking of you, wondering if they made the right choices too. And maybe that's enough, to know that, across the vast ocean of possibilities, every version of you is simply trying to understand what it means to be alive. It's easy to feel small when faced with infinity, but there's a secret comfort in remembering that infinity doesn't make you insignificant. It makes you irreplaceable. Because even if countless universes exist, none of them can ever be this one. The version where you're listening now, with this breath, in this moment, in a sea of endless branches, this single leaf is yours. You are the awareness that makes it real. Without you, this world would remain only a possibility, unobserved, unspoken. You are the universe's way of seeing itself, briefly, beautifully, through human eyes. When you look back on your life, you might notice the small turning points that shaped it. They rarely arrived with fanfare. Most were quiet, a decision made on a tired afternoon, a sentence spoken without thought, a door left open or gently closed. Each one became part of a pattern too intricate to see while you were still inside it. But from here, in reflection, you can sense the symmetry, how the right people appeared at impossible times, how chance became meaning, how even loss carried hidden gifts. The multiverse may be infinite, but so is gratitude. It allows you to look at every fork in the road and whisper, "Thank you for leading me here." Science can describe the universe in equations, but life is written in feelings. The warmth of a hand, the ache of parting, the relief of forgiveness. These are the phenomena we measure not in numbers but in heartbeats. And if you listen to your own pulse, slow and steady, you can almost hear the rhythm of creation itself. Not a grand explosion, but a soft unfolding. Every breath you take is the continuation of that first cosmic expansion, the echo of the universe still growing, still learning to exist. So when you think about the other lives you might have lived, let the thought be gentle. Don't mourn them. Don't chase them. Imagine them like pages in a book you haven't read yet, or stars you'll never reach but can still admire. They belong to you, but you belong to this one, the chapter where you're awake, where your story is being written in real time. Somewhere out there, other versions of you are doing the same, each one discovering their own kind of peace. You don't need to visit them to know they're safe. The universe doesn't lose what it creates, it only redistributes it. If there's a truth that runs quietly through everything we've explored, from quantum waves to cosmic horizons to the landscapes of memory, it's this: reality responds to attention. What you love grows. What you fear sharpens. What you ignore fades. You're not separate from the world you see. You're part of its living equation. Every time you notice beauty, you increase it. Every time you act with compassion, you strengthen the threads that hold the universe together. Perhaps that's the simplest, most human form of physics. Cause and effect transformed into care and awareness. Every small act of kindness, every moment of wonder is its own kind of gravity, pulling the world gently toward harmony. And when you look up at the night sky, remember that your gaze isn't one way. Those same stars, born billions of years ago, are still shining into your eyes, completing a circuit that began before you were born. The universe sees you too. In that light, the multiverse becomes less a maze of endless choices and more a mirror of infinite grace. It doesn't ask you to understand every path, only to live this one with attention, to inhabit your own small corner of infinity with kindness and curiosity. Every version of you contributes to the greater story, but this version, the one holding this moment, has something no other world can: presence. You are here, you are now, and that is everything. So take a moment, right here at the edge of the story, to feel the quiet weight of that truth. The galaxies spin, the atoms hum, the equations unfold like poetry, and somewhere between all of it, there's you, a brief flicker of awareness in an endless sea of being, noticing the light, listening to the stillness, shaping reality by the simple act of caring that it exists. Don't mourn the lives you didn't live. They are safe somewhere, in the soft archives of the cosmos. Every choice, every dream, every heartbeat recorded in the memory of the whole. You don't get to visit those other worlds, but you carry their echo. They are your unseen companions, watching through the glass, grateful that you were the one who took this path. And when you close your eyes tonight, let that thought rest beside you like a calm tide. The universe is vast beyond measure, but it also fits perfectly within a single breath. You are both the dreamer and the dream, both the question and its quiet answer. This life, your life, is the point where infinity becomes intimate. Live it gently. Live it fully. Live it as though the universe itself were leaning closer to listen. And so, we've reached the end of our journey tonight. Whether your eyes are still open or already drifting into sleep, thank you for being part of this quiet exploration. If you enjoyed wandering through the many worlds with me, I'd love for you to like this video and subscribe, not out of obligation, but so you can join me again the next time we drift through the cosmos together. Until then, may your thoughts settle like dust in sunlight, and may the world feel soft beneath your dreams. Somewhere, in one of those endless realities, another version of you is listening too. Sleep peacefully, traveller, in this universe and in all the others.